202,586 people applied to leave Earth. Not for a vacation, not for a few months, but forever. They saw the radiation numbers, which is 22 times the legal safe limit. Up to 1% bone loss every single month. They knew the skeleton starts dissolving within 48 hours of leaving Earth. The heart shrinks by 20%, and the genes will change permanently. They knew all of it, and still asked to go first. But here is the part nobody mentions. The most dangerous moment of this entire mission is not landing on Mars, but it is coming back home. But the most disturbing part of this story is not what Mars does to the people who go. It is what it does to the children born there. A child raised in 38% of Earth's gravity develops bones and a heart built for that world. Earth, the planet their parents once called home, would crush them. By the end of this video, you will understand why the scientists who designed this mission already know their astronauts are never coming home, and why they are sending them anyway. Before we go further, I have a question for you. Would you still go knowing you would never come back? Drop yes or no in the comments. By the end of this video, that answer will not be as simple as you think. And if nobody has told you about this channel yet, every week we go somewhere. Most people are not ready to go. Hit the subscribe button and like the video. This is only the beginning. Now, let us talk about what returning to Earth actually does to a human body, and why the people who designed this mission have quietly stopped planning for it. Imagine you volunteered. You passed every test. You survived the 9-month journey. You step onto the surface of Mars, the first human footprint in rust-colored dust. You look up. In the pink Martian sky, there is a tiny blue dot, barely visible, smaller than a period at the end of a sentence. That is Earth. That is every person you have ever loved. Every hospital, every forest, every ocean, every breath of clean air you have ever taken, and you will never reach it again. Not because the journey is too expensive, not because the technology isn't ready, but because Mars itself, the gravity, the radiation, the atmosphere, the biology of your own body will make the return trip a death sentence more certain than staying. Here is the question no space agency publicly wants to answer. If we send humans to Mars, are we sending explorers? Or are we sending permanent residents who just haven't been told yet? Mars is not hostile the way people imagine hostile. It is not dramatic. It does not explode. It does not swallow you in lava or crush you in an instant. Mars kills slowly, quietly, and with extraordinary patience. The atmosphere is 95% carbon dioxide. Surface pressure is 0.6% of Earth's. You step outside without a suit, and your blood begins to boil within seconds. Not from heat, but from the pressure drop. Your lungs collapse. You lose consciousness in 15 seconds. You are dead in under 2 minutes. The average surface temperature is minus 60 degrees Celsius. At the poles, it drops to minus 125. And the radiation. On Earth, our magnetic field and atmosphere absorb the constant bombardment of solar particles and cosmic rays. Mars lost its magnetic field approximately 4 billion years ago. Its atmosphere, what remains of it, provides almost no protection. A human on the Martian surface receives 0.67 millisieverts of radiation per day. That is 22 times the daily dose considered safe for a radiation worker on Earth. Over a 500-day surface mission, a Mars astronaut would absorb roughly 1,000 millisieverts of cumulative radiation, crossing the threshold that the International Commission on Radiological Protection associates with a significant, measurable increase in cancer mortality. But that's not the terrifying part. The terrifying part is what happens to the body before the radiation kills it. In microgravity, during the 9-month journey to Mars, the human body begins to dismantle itself. Bone density decreases at approximately 1 to 2% per month. Muscle mass atrophies. The fluid in the spine redistributes upward, compressing the optic nerve, causing permanent vision damage in a condition called spaceflight-associated neuroocular syndrome. The heart weakens. The immune system becomes erratic. NASA astronaut Scott Kelly spent 1 year on the International Space Station. His telomeres, the protective caps on his chromosomes, the biological markers of aging, showed measurable deterioration. His gut microbiome changed. His gene expression changed. He was in low Earth orbit, 400 kilometers up, still within Earth's magnetic field. Mars is 225 million kilometers away. What scientists found when they modeled the full Mars mission profile changed the calculus of everything. Here is the number that no one says out loud at press conferences. A round-trip crewed Mars mission using the best currently available propulsion requires a minimum of 21 months. 9 months there, 3 months on the surface, waiting for the orbital window. 9 months back, that is 21 months of radiation exposure, 21 months of bone loss, 21 months of cardiovascular degradation. Studies modeling the full mission profile estimate that by the time an astronaut returns from Mars, they will have absorbed radiation equivalent to a lifetime occupational dose, compressed into under 2 years. But the return journey is not just dangerous. It may be physically impossible, not technically and biologically. After 9 months of transit in microgravity and 3 months in Martian gravity, which is 38% of Earth's, the human body will no longer be capable of tolerating even a 1-gram environment. Standing upright in normal Earth gravity after that duration of deconditioning would be like asking someone to lift their own body weight after 21 months of total bed rest. They could return to Earth and unable to walk. Some researchers believe the cardiovascular system, after that duration in low gravity, may not recover sufficiently to survive re-entry and the return to full Earth gravity at all. That is not a theory buried in a footnote. That is a published finding from human spaceflight medicine researchers, people whose job it is to keep astronauts alive. And that's not the worst part. The worst part is the launch problem. To leave Mars, you need a rocket. That rocket needs fuel, and that fuel needs to either travel with you from Earth, adding catastrophic mass to the launch vehicle, or be manufactured on Mars using local resources in a process called in situ resource utilization, ISRU. It sounds straightforward, and to be honest, it has never been done at that large scale. It has never been done in Martian conditions. It has never been done with a human life depending on it. The mass of fuel required to lift a crew vehicle off the Martian surface back to orbit is approximately 30 metric tons. 30 metric tons of fuel generated on a planet with no infrastructure, no supply chain, no spare parts, no rescue mission within 9 months of arrival at the absolute minimum. A single equipment failure, one pump, one seal, one unexpected dust storm lasting 100 days, which Mars does with regularity, and the fuel is not made. The rocket does not launch. The crew does not leave. SpaceX knows this. NASA knows this. The researchers who publish the biology papers know this. And here is what none of the promotional materials say clearly. The architecture of every serious Mars mission ever proposed, from NASA's Design Reference Architecture to SpaceX's Starship deployment plan, is built around the assumption that the first crews may not return. Not as an acknowledged tragedy, not as a caveat in small print, as a design feature. The logic is this: if you carry return fuel from Earth, the mission mass becomes so large, it is currently unfeasible with any existing or near-term launch system. If you manufacture fuel on Mars, you depend on technology that has never been proven in that environment. Both paths carry unacceptable risk of stranding the crew permanently. The proposed solution from several mission architects is to simply not plan the return trip at first, send people, establish the base, keep them alive, send more people, and treat Mars not as a destination you visit, but as a place you populate. Elon Musk has said publicly that early Mars colonists must be prepared to die, not in a reckless sense, in an actuarial one. The mission profile, the radiation budget, the bone density projections, the fuel manufacturing dependency, they all converge on the same quiet conclusion. The first humans on Mars will likely live there for the rest of their lives. Those lives will likely be shorter than they would have been on Earth. They will watch their bodies aging faster. They will watch their vision degrade. They will know with scientific precision what the radiation is doing to their cells every single day. And here is the thing that should keep you awake at night. When NASA and ESA and SpaceX announced Mars missions, volunteer applications surged. Tens of thousands of people applied for the Mars One program, a project that was always transparently a one-way trip. They knew, but they still applied anyway. This is the moment we have to look at ourselves honestly. We are a species that, when presented with a journey of 225 million kilometers, knowing the radiation will shorten our lives, knowing the gravity will break our bodies, knowing the fuel may not be made, knowing the rescue mission is 9 months away at best, produces not a shortage of volunteers, but a surplus. This says something about us that no space agency press release ever addresses. We evolved for movement, for crossing the next hill, for reaching the far shore. The impulse that drove the first humans out of Africa, across land bridges, across oceans in wooden boats with no guarantee of return, is the same impulse that fills out the Mars application form. We do not leave because it is safe. We leave because we cannot help it. But there is a weight to this one that history's other migrations did not carry. When the first humans crossed into the Americas, they breathed the same air, they drank liquid water, They stood under a sky with oxygen in it. Mars offers none of that. The first Martian colonists will live underground or in pressurized habitats. They will never feel wind that won't kill them. They will never drink water that didn't come from a machine. They will never look up and see a sky they can survive in. And if civilization on Earth collapses, pandemic, asteroid, nuclear war, any of the scenarios that Mars colonization is explicitly designed to hedge against, they will not know. The signal delay between Earth and Mars is up to 24 minutes each way, a 48-minute round-trip conversation. Events could unfold and end on Earth before the people on Mars received the first transmission. They would be alone in a way no human being has ever been alone, and they chose it. That choice, that specific, informed, clear-eyed willingness to trade everything familiar for the most hostile environment in the accessible universe, is either the most heroic thing our species has ever produced, or a quiet form of madness we have decided to call exploration. Perhaps both. The first Mars landing is currently projected for some time in the 2030s. The astronauts who go are probably alive somewhere right now, going about their day. They may not know yet that they are going, but when they arrive, when they press that first boot into Martian dust and look up at the tiny blue dot that used to be home, the last thing they will see before the pink sky closes around them is a world they will spend the rest of their lives remembering, and the rest of their lives will be spent on Mars. The only question left is how long that is. So if this is the kind of truth you want to keep exploring, and the kind that stays with you, then subscribe, like, and comment, because this is only the beginning.